Record. And then I'm going to share a screen and we're going to go into the agenda for today. And here it is. This should say the 7th, not the 12th. Or excuse me, not the 5th, but the 7th up here. So we'll make a change on the fly. So anyway, review any homework on chapter 7, lesson 4, 5, and 6. Then we'll do a short lecture on geometry on surface area. And then we'll review for the final on Wednesday. And it's going to cover all chapters. And I've had a short version and a long version of this test, and I'm going to give you the short version. The short version is still 8 pages, so it's not that short. But to me, it's short. But it's
Yeah,
try
that.
to make it comprehensive. Put it that way. That was my goal. And so if you can, and I'll provide the key after the test, of course, and I'll grade your test and give you the feedback on it. But anyway, that's what we're going to do. So for today, is there anything, Jessica, particularly on lesson 4, 5, and 6 that you want me to go over?
Nope.
No,
I
it
was
was pretty
gonna get to it.
straightforward, right?
Yeah,
And
yeah,
yeah,
it was.
that's what I thought too. Okay, so let's look at chapter 7, surface area, lesson 7. Okay, stop sharing that. We'll go here. We'll go here. We'll stop sharing. Okay, so can you see my screen?
Yeah.
Okay, surface area. Um, and first they talk about surface area of a prism. Square prism is just it's any block that has all sides equal, basically. So they show the formula. The surface area would be 6 because there's 6 sides times s squared because each side is s. So one particular face of it would be s times s or s squared. And there's 6 faces, so it would be 6s squared. So if you had a 3-inch um, square prism, it would be 6 times 3 squared, or 6 times 9, or 54 square inches in this case, okay? Um, so if it's not a square prism, if it's a rectangular prism, you just have to, well, they use the formula like this. The perimeter times the h. In other words, you go around the outside of the block, add up all the sides, and then get the height. That'll give you the surface area, the 4 sides around the block. And then you'd add 2 times the base, because there's a base on the top and a base on the bottom. There's a number of ways of getting this total area. This is just one little formula that they would
So
use.
what's the H
The
height,
H
right?
is the height, yeah. In this particular
And
case
the
would be
P?
7. Yeah.
What's
And
the
P,
P?
what's the P? That's the
Yeah,
perimeter.
perimeter.
That's the
Okay.
length around the outside of this thing. Okay. I mean, this is one there's a number of different formulas you could use, but in fact, I've never really seen this one like this before. So,
Oh.
but they all work. The point is you want to get the area of each side. So however you want to do that, like look at this block right here. It's a 5 by 6 by 7. Well, you could say 5 by 7 to get this side. It would be the same as the other side. So it would be 2 times 5 times 7. That would give you the 2 outsides. Then you can do the 2 other sides, which are 6 by 7. There's 2 of those. And then there's the top and bottom. It's the 5 by 6 and a 5 by 6. However you want to add them all up, you can add them all up. But the point is you just want to account for every area. That's all. Okay.
For
And
every
this is
side.
just one formula of doing it, where they take the perimeter of the whole thing times the height, then add the 2 bases, the top and the bottom. And remember that capital B means the area of the base. That's what that capital B is. Okay. So that's one way of doing it. And then you've got another example here, and that's the surface area of a pyramid. In this particular case, it's a square pyramid. In other words, it's square in the base. On the bottom is a square, and the vertex is the point where all sides go up to that point, right? And so the surface, and what we're trying to do is measure the surface area of this thing. So the surface area happens to be 1/2 times the perimeter, that's the base, times the S, which is the slanted height. That's the actual height from the bottom of the pyramid, from the middle of the bottom of the pyramid up to the very top. So it's right here in this diagram. That's the slanted height. Okay, it's not from the middle up to the vertex, but it's from this edge of the side. Not only that, it's the middle of the edge of the side. Okay, it's the middle, not the edge, but it's the middle. And that would be, and then it would be that plus the base, and the base would just be this side times this side because it's a square. Okay, so that's how you'd measure the um, the surface area of a square pyramid. Okay, that formula can be used: 1/2 times the perimeter times the S, which is the slanted height, which is just like they show here, plus the base. Okay, and it gives an example. Well, anyway, it doesn't put the numbers in here, but it does give an example. We'll go on to the next page and you'll see more. We'll have some examples on that next page. Okay. Okay, so the next page is like this, and so it's find the surface area of each object. Number one, you could take the perimeter times the height, so it would be 4 plus 6 plus 4 plus 6. That's 20, and the height is 3, so it would be 60 for the outside sides, and then the top and the bottom. The bottom and top would be 24 each, 4 times 6. So it'd be 48 plus 60, so 108 square units. You don't know what it is, but it's a unit. Okay, it's square units. Or you could just go ahead and just add up all the surface areas, the outside edges. However you want to do it, it doesn't matter. The point is you want to count for every edge or every surface, right? That makes sense?
Yep.
Sarah, are you with me on that?
Yeah.
Okay, all we're doing is just measuring the surface area of the outside of these objects, that's all. So 1, 2, and 3 are all pretty well the same thing. But look at number 2. Here you've got a square pyramid here. And it gives the length of the edges. So the base would be 3 times 3, or 9 square inches in this case. And then it's 1/2 times times the perimeter times S, and S is 5 inches, just from here to here. So the perimeter would be 3 plus 3 plus, so it'd be like 12 times 5, which is 60, divided by 2, which is 30. So it'd be 30 plus 9, so it'd be 39 square inches. Okay. And number 4 is done the same way, exactly the same way, right? Any questions on those? You just have to know that one little formula, and you can do all these quite easily, right? Okay, what about number 9? If the dimensions of the box below are doubled, by how many square centimeters does the surface area increase? That's interesting. So you got to do a little math on that, right? If the dimensions have doubled, every dimension is doubled. What's that do to the surface area?
Doubles.
Well, more than doubles, because if each side is double, what does it do to each side? I mean, each surface. What if each side is doubled? What's it do to each surface area? Just think about that.
Make them 6.
Not 6, no.
What?
Well, it would, if each side is doubled, I'll just go to I'll show you my deal here.
So yeah, wouldn't all these sides that they have here just turn to 6? And
Not
then
6,
that
no.
formula? Or I'm confused.
No, not 6, but
Okay.
here, I'll try to show it to you here.
Okay.
See if I can, oh, I can do a slide.
Oh yeah, times 6.
Oh, it's like this. Um, darn it, just a minute. I'm trying to see if this makes sense.
You got good at that.
Yeah, I'm getting better, getting better. Okay, so it's like that. But what we're saying is each side is doubled. So what that means is that this, I'm gonna do a different color here maybe. This side goes out. If I can do it. Come on, Tulsa. Yeah, just when I say I'm getting good, doubling that side, and I'm also doubling this side. Right? So what that means,
Mm,
just think of it. Each side is going to be this much more, Jessica and Lucero, right?
mm.
Right? I'm
Okay.
doubling, right? So I'm
Yeah.
doubling each side. So this whole thing's four. Well, it ends up being 4 times as big. Each side, because each side the area of each side is like S times S. Will be like 2S times 2S, right?
Oh. Mm.
Think of it that way. So it's like 2S instead of just the S up here, right?
Yeah.
And what we're doing with to get that surface area, we're squaring it. So the area of one side, area of just one side would be 2S times 2S. Well, what's that equal to? That's equal to 4S squared as opposed to S squared.
Oh,
Yeah, you see what I'm saying?
gotcha. Yeah.
Yeah, see, area initial just would be S times S, right?
Mm.
So I'm just trying to show you that it ends up being
Yeah.
S squared like that. So the difference is 4, not 2,
Oh,
but it's 4. So that's what I'm saying.
gotcha.
The surface area is increased by a factor of 4, each one of these surface areas, right?
Mm-hmm.
That's what that means. And you got 6 of them, so that's 24 times as big as just the S. When you have S squared, the surface area is increased by 24 times because you add them together. You've got 4 plus 4 plus 4 times 6 is 24. I mean, stop sharing that and go back to that thing here. Why don't we have 24 in here? 8. How many more square centimeters? How many more square centimeters does the surface area increase?
So we have to find what it was at
Yeah,
3.
yeah, exactly. And so here's what it is 3 times 3 times it's a cube of 3 times 3. So each side is 9. You've got 6 nines. 6 nines is 54. The new version, you've got 6 times 6 times 6. Because in other words, each side is going to be 6 by 6. So it's going to be 36 times 6. And 36 times 6. You see where I am? Does
Yeah.
that make sense? Okay. So I'm checking something. Just a minute.
Mhm.
Okay. So on the new version, then I'll stop sharing this and I go back here and share this right here. So in this particular case, the surface area of the first one is 3 times 3, right? We said it was because each side is 3 times 3, and there's 6 sides, so it looks like this. So that's equal to 54. Okay, 9 times 6 is 54. The second S2 surface area of the second one, when we increase everything by 2, it ends up being 3 times 2. Each side is 6 instead of 3. So it's that times the same thing times 3 times 2. And that whole thing times 6. So that's equal to 6 times 6 times 6, right? And 6 times is 36 times 6, which is, I'm not sure what it is. What's 36 times 6?
216.
Okay, it's 216. Oh, crud, I lost my, darn it. Ah. So it was, yeah, it was,
D.
yeah, I know, I'm just gonna.
Oh, okay. I was just
Yeah.
trying to.
No, that's okay. So it's 216, that's what you said. So that's so it went from 54 to 216. That's how much it increased by.
Nice.
And if you divide 54 into 216, you'll get 8. And 8 is the answer they're looking for in that, right?
Yeah.
That's how you do that problem. Okay. Okay, I want to keep going because I don't want to spend a lot of time on this stuff. But that's how you do those, okay? Let's look on the next one. Stop sharing that. And we'll go on to the next one here. Right here. And here we just have, we're still in surface area because that's all we're doing. And we have cylinders and cones, okay? Okay, a cylinder, we figured out what the volume was, but the cylinder, all we're doing is we're taking the base, the top and bottom, and then adding the wall of the side, right, to get the surface area. So they come up with the formula. It's 2 pi RH. This is 2 pi r is the perimeter of a circle. Okay, that's pi d or 2 pi r, and then times h will give you that whole. It'll give you the wall around that cylinder, and then you're adding 2 times the base. The base is pi r squared, so that's the bottom and top. So it's 2 times pi r squared. So you end up with 2 pi r h plus 2 pi r squared. That gives you the surface area of the whole cylinder. Okay. And then on a cone, you've got the base, so it's pi r squared. That's that part right there. And it's pi r times this, pi this, okay, they use a slanted height on this thing. This S is slanted height, not the height. And it's pi rs. So, and with that, like, there's no, yeah, that's it. It's pi r 3.14 times the radius times the slanted height. So add both, and that's for the surface area of the cone part of it, not the base. And add them up, and you get the surface area of the whole thing. Okay. You're not expected to know these formulas, okay? Surface area of a sphere. This is the air. This is the formula: 4 pi r squared for the surface area. So if you know what r is, you could figure it out. You could figure out the surface area of the Earth, right? If you know what r is. R is something like 6,000 miles or something like that. You could throw that in there, and you get a pretty good idea of what the surface area of the Earth is. Okay. Okay. It's a lot of land. Okay.
Yeah.
Okay, so I'm going to stop sharing that. We'll go on to the next page. And again, on these, if you just use the formula, you can get these. There's nothing, there's no tricks or anything to it, right? Here's a surface area of a short cylinder, right? The radius is 5, the height is 5, or the radius is 7, the height is 5. So it's pi r squared for the top and the bottom, so it'll be 2 times pi r squared, times the perimeter, which is pi r2. That'll give you the perimeter, and then times the height, and then you add them all up, and you get your surface area of the whole thing. Okay. And this one would be like surface area of a sphere, and that's that formula, which I can't remember what it is.
The 4 times pi r squared.
Okay, that's pretty simple, really, to use that one. Okay. And here's another one that's the same as 3. And here's a cone. So the base plus the height plus that's the surface area of the cone part of it, and you use the slanted height in that formula. That's what 6 is in that case. Then you're back to a cylinder again. Then you're back to a cone. Okay. Anyway, so just use those formulas, and you can figure that out. Okay. Go on to the next page.
Oh, joy.
What's that?
Combined.
Well, yeah, and okay. Actually, we're not gonna.
Oh.
Yeah, we're not gonna do that. Let's not worry about that. It's just more of the same. Okay.
Yeah.
At this point, I want to stop. I want to stop this, and I want to start going over what you'll see on the test on Friday, and it's meant to be comprehensive. Okay.
Friday.
Or excuse me, Wednesday, not Friday. Sorry. Well, my Friday, your Wednesday. No, that's not true. But anyway. And so what I've done is I've uploaded in Canvas, and I'll send you an email on it too, an attachment. I've uploaded a final, but it's larger than the final that you'll take. Okay, so this one's got all extra problems in there. I've boiled it down to try to be sort of representative of the whole text. Okay, so I boiled it down to 8 pages, and made it shorter. But my point is, if you go over this final on your own, and if you can answer comfortable on knowing how to answer all those problems, you'll do fine on the test on Wednesday. It won't be hard at all. So today I'm just going to go through subject by subject. Okay, so I'm going to start, and the first thing we're going to talk about is rounding. Okay, remember we spent time in rounding, so I'm going to show this. These are all the areas that I want you to feel comfortable with. So if you were to round a number like 21.478 and I say, okay, round this to the nearest hundredths. You round to the hundredths. Well, you got to understand where hundredths is, right? You spell it right. That would help. If I'm saying round this number to the nearest hundredths, what I'm saying is I'm going to round this number to this number right here, right? This is in the hundredth column. Oh, that's stupid. Make it thicker. Round. I want to round it right to that number right there, to the 7. Okay. So how do I do that? I look to the right of that, right? I say, oh, this number is 5 or greater. It's a 9. It's 5 or greater, which means that the 7 has to be rounded up by 1. So this number rounded to the nearest hundredth would be like this. That would be the answer. Okay. You don't put anything to the right of that. You just stop at that 8 because I'm saying round to the nearest hundreds. So 21.48 is this number rounded to the nearest hundreds. Okay. That makes sense?
Yeah.
Okay. Lucero, are you okay with that?
Yeah.
Okay. So now let me give you another one. So what if I said 458.297 89? And I'm saying round this one to the nearest hundreds. What's that number going to look like if I say round to the nearest hundreds on this one?
Be 0. Wouldn't it be 10?
No. Well, what's the number going to, what's the total number going to be? 458.
Mm-hmm.
Point what?
0.30.
You good with that? Lucero, does that make sense?
It does make sense.
Okay, so we're taking that, I just want to make sure you understand that, both of you guys, but you're right. We want to round to there. Look to the right, this is larger, so I'm going to add 1 to the 9, it makes it 0. And so if this is 0, then this is 3. So you show your number like this, right? I want 458.30. Don't put 0.3, but 0.30, okay? Because I'm saying round to the nearest hundred. Okay? Okay, let me give you another example with some decimals in it. So if I say round this one to the nearest tenths, okay, I want to round this to the nearest tenth. But what I do in this one? Where is the tenth?
It's right there.
It's the very first one, right?
Mm-hmm.
That would be the tenth. So if I want to say I want to round this to this, what do?
You leave 0.02, right?
Nope, that would be rounded to the nearest hundredths.
Oh yes, sorry. It'd be
Okay,
the exact same thing right there.
well, but okay,
0.
well,
right?
what's the answer going to be?
0.0.
Yep, exactly. That's. It seems like you wouldn't. That might not be intuitive, but that's exactly what it is.
Okay.
0.0. That would be rounded to the nearest tenth. Okay. What if I said round it to the nearest thousands? This is tenth. This is a hundredth.
It would be
Okay. Wait. Lucero, why don't you answer that? Can you answer that for me? I want to round this number 0.01528 to the nearest thousands. What would that be, do you think?
Would that just be 1/6? So like 16, because I'll just be 1 up it.
No, it wouldn't be one. No, it's not because. Well, here's the thousands place. It's the 5, right? That's the thousands. So you look to the right. That number's not 5 or greater. So you
Oh,
that 5
that'll
is a
be
5.
4.
No, it'd be 5. It's going to stay the same. So this thing rounded to that place. Just make sure. Let me get my little scribe board up here. Yeah, that's why I want to go over these so you understand it thoroughly enough so you can do only the easy ones, the hard ones. Second. Okay. So I have this. So what I'm saying, and let me trying to use my pen here. So what I'm saying is we want to round to that point, right? To that place. When I say 1,000, that's what it is. I look to the right, it's a 2. It's less than 5. So this 5 doesn't change. So it ends up being 0.015. And you don't go any, that's supposed to be a 5. You don't go any more than that. That's your answer. Okay? Does that make sense now?
Yeah.
Lucero? Yeah, so we don't, that 5 doesn't, it never goes to a 4, for one, I mean, if I'm rounding to the thousands, it's either stays the same or I add 1 to it. It doesn't go, I don't go negative. I mean, I don't go lower than that number. Okay.
Okay.
Okay. So let's do one more. What if we had like 423,259. And I'm saying round this to the nearest 10th or a 10 place. First of all, you got to know that this would be the ones, the 5 would be the tens, the 2 would be the hundreds, the thousands, the 10,000s, 100,000s. So when I say round to the nearest 10 place, what would this number round to? Jessica, what would you do in that one?
It would be 4, 2, 3 to the 10th.
Yep, to the 10 place, yeah.
It would be 4, 2, 3, 2, 6, 0.
Exactly, that's what it'd be, okay? And what if and Lucera, what if I said round it to the nearest 100 place? What would it be? I want to round this thing to this place right here, to the 2.
It would be 4, 2, 3, and that
Yeah.
would be it.
No, I want to round it to this place right here. So I want to look to the right of that. I'm not over here looking to the right. I'm looking at 2 to the right. So I look at a 5, right? And 5 is 5 or 9. If it's 5 or 9, you add 1. You would add 1 to that 2.
So that would just be 4, 2, 3, 3.
Exactly. So you'd write it like this. You'd put zeros after that 3. Okay. 423,300. Okay. That's how you would do it. If I said rounded to the nearest 10,000, what would that be, Jessica?
It would be 4, 2, 3 because it's
No, the nearest 10,000, not 1,000.
10,000.
This one right here.
It would be the 2. So it'd just be 4, 2, 3, 2, 5, 9.
No.
Or
None of these, all these go away.
are they what?
Well, if I'm saying rounded to the nearest 10,000s, I don't want to look, anything to the right of that is going to be zeros.
Okay, so it's 4, 2, 0, 0, 0, 0.
Exactly, 420,000. That's how you would write it. Okay. And what if I said I rounded to the nearest, well, to the nearest 1,000 place? Here's the 1,000 place right here, the 3, right? So I say rounded to that. I look to the right. This is less than 5. This thing doesn't change. So what's the answer? To the nearest thousandth place, what does that look like?
4, 2, 3, 0, 0, 0.
Exactly, okay. Does that make sense, Lucero?
Yes.
Okay. You guys got to understand that. Okay. So I think we've gone over anything less than 1 and how you look at that and anything greater than 1. Okay, so something like that will be on the test. So understand how to do that, okay? And on the test, you can use notes, okay? Any notes you have, you can use. Okay, so that's the first thing. Okay, now change the subject, mixed numbers, okay? We'll talk about mixed numbers. Okay, here's a mixed number. Mixed numbers and improper fractions. A mixed number, 5 1/3. Okay, that's a mixed number. It's mixed because it's got a whole number and a fraction. That's what makes it mixed. I say, okay, I want to know what this is in the improper fraction form. Improper fraction is where the numerator is larger than the denominator. And you you convert this by multiplying the denominator times the whole number. So it ends up being like this, 3 times 5 plus, whoops, plus the 1, the numerator, and that whole thing is divided by the denominator of the fraction. Yeah, you should know how to convert all these. Okay, that's what it would look like. And we're not done, of course, so we got 3 times 5 is 15, plus 1 is 16, so it's 16 over 3. This is the improper fraction version of that. Okay, that makes sense?
Yeah.
That's how you do these. Okay, mixed number, improper fraction. So that's, and then let's go the other way. Convert the improper fraction to a mixed number. What if we had 21 over 4? How do we convert that? And I'll show you how to convert that.
Well, you put
Go ahead.
4 over 21 over 4.
You put
And
21
then you
over
put
4.
the 4 divider thingy.
Yeah,
21.
It looks like this,
Yeah,
right?
that's, yep.
4 into 21. And so you ask yourself, how many times does 4 go into 21? How many times does it go?
Maybe 5.
Be 5, right? 5 times 4 is 20. Subtract that from 21, you get 1. So remainder is 1. So now take that and write it in the mixed number form. What's that equal in mixed number?
It is, I forget, hold on.
It's okay.
20 minus 1 would it be like 4 over 1 5?
No. What you do is you
1
take,
4.
well, look at, first of all, your whole number is 5, right? Okay, 5, and then it's 1 over 4.
Yeah, 1 over
That's
4.
okay. This would be the mixed number form of this, right? That's how you get there, right? So understand how to do this, okay? Lucero, does this make sense? That's what we're doing. I'm going to do one more down here.
Yeah.
You see, it's important that you understand the steps, how you do it. If I have an improper fraction like this, I have to divide the denominator into the numerator. That's what I'm doing here in long division. And I get 5 with a remainder of 1. That's converted to a mixed number. This becomes the whole number, the 5. And the remainder is the numerator, and the denominator is the divisor, what you divided originally by. Okay, so it becomes 5 and 1/4. I'll do another one. We'll do another one right here. But it's important to understand how to do these. So take notes so you can look at this and figure out how to do it. Okay.
Yep.
Okay, so let's do another one. Let's do 17 divided by 2. Okay. This is my improper fraction. I want to convert this to a mixed number. So what do? We're going to take the divisor and we're going to divide it into the top number. So I'm going to go like this. I'm going to change this. So it becomes 2 into 17, right? How many times does 2 go into 17?
Would it be 8?
It would be 8, right? And 8 times 2 is 16. 1 left over, so it's a remainder of 1. So how do I write this as a mixed number?
8 and 1/2.
8 and 1/2. Okay, Lucero, do you understand that?
Yeah, I do.
Okay, it's important that, yeah, just you gotta know how to do this. So we just went from, oh, come on, Chelsea. That's not what I was trying to use a square, but anyway. Yeah. We went from this to this is what we did. And we used the manual division to do it. Okay. So know how to go this way and know how to go back, do the other way. Okay. Okay, so understand that. That'll be on the test. More. Okay, so now evaluating and simplifying expressions with mixed numbers. That's why it's important to know how to do this, because if you had a problem like this, I'll just throw something up here, 8 and 1/3, and I'm saying add that to 9 and 1/2.
Crap, I forgot about these.
How do you do it? Yeah, well, don't forget about these. They're not going to go away. Okay, so what we have to do, don't worry about the whole numbers right now. Just worry about the fractions. We can't add 1/3 to 1/2. We have to have the same denominator. So in this particular case, if I had 1/3 and 1/2, what would be a common denominator I could use on both that I could factor each into or to make? In other words, what
B
if
to get to 6.
a 6, right? If I used 6, so I want to turn the 1/3 into 6, so I have to multiply the top and bottom by 2, right? So then I get 1 times 2 divided by 3 times 2, or 2/6, right? And I have to do the same thing with the 1/2. And the 1/2, I have to divide the top and bottom by 3, right? So then I get 3/6. So now I can rewrite this thing. I can look at just my fractions, and what I'm going to do is just sort of add the fractions together. Right? And I've got them in this form down here, so it becomes pretty simple. It becomes 2/6 plus, oops, plus 3/6, right? 6. And so the numerators can be added together. So I'll just show the work. 2 plus 3 all divided by 6, which is equal to 5/6, right?
Mhm.
So now I've added up those. Now I can add the whole numbers and then add them to this fraction. So when the dust settles, I've got 8 plus 9 plus 5/6, right? And that's going to be equal to 17 and 5/6. Okay, that would be your answer. It gets a little more complicated when you've got, well, more cumbersome looking fractions, and they become larger than than a whole number. So in other words, if I had another one, like we'll do another one right here, we'll make it 4 and 5/6 plus 3 and 1/4. Yeah, 1/4. Let's say 1/4. Okay, so I look at 6 and I look at 4. I'm looking at my denominators here. What would be a common denominator I could use to add these two fractions together with?
It would be
What would it be?
Wouldn't you want to get it to 12?
You could say 12, yes. 12 would be a good one. You could go all the way up to 24 if you wanted. You could just say 6 times 4, but you could do 12. 12 is the lowest common denominator. So let's use 12. So I want to convert the 5/6 to 12. So what do I have to multiply the numerator and denominator by?
It would be 2 for the 5/6 and 3 for the 1/4.
Okay, so it's 5. So it'd be 5/6. It'd be like that. And I'll show my work. So it'll be 5/2, right? All divided by 6 over 2, right? 6 times 2. So I've got 5 times 2 is 10, so it becomes 10 over 12, right? So we did all that work just so we could convert this, this 5/6 into 12s. Now we're gonna do the same thing with the 1/4. 1/4, I have to multiply the top and bottom by 3, right? So it look like that. So then it would be 1 times 3 on top. I'm just showing my brackets here to show it. And then the bottom would be 4 times 3. Right? So the top is 1 times 3 or 3 divided by 12, right?
Mhm.
Okay. So now I put these back into this equation. And just look at the fractions alone to start out with. So here we've got 10 12 plus 3 12. Sarah, what's 10 12 plus 3 12 equal?
13 twelfths.
Exactly, 13 12, right? Okay, so I have 13 12. Now this is an improper fraction. I don't want an improper fraction. I want a mixed number. What's this equal to in mixed number form?
Which one?
In 13 12, what's that equal to in mixed number form?
Would be 1
Okay.
and remainder 1.
Okay, so you took the 12 divided into 13, right?
Mm-hmm.
And so what's the fraction form then? 1 in,
It'd be 12 and
not
what is
12. Well, no, just I want to just worry about the 13 12. In other
yeah,
words,
yeah. It'd be 1
yep.
and hold on, I wrote it down.
Okay,
And remainder 1, so it'd be 1 1/12.
there you go. That's what I want. 1 and 1 12. So now I've got all my parts, right?
Mhm.
So now I'm gonna slip gears here. So now what do I have? I figured out I'm going to take this and add it to this and this, right? Because the 5/6 and 1/4 is equal to that. So you just got to keep track of all this stuff. So then the
Yeah.
4 and 7, the 4 and 3 is 7. So then it looks like this, right? And then add the 7 and 1 together, so you get 8 and 1/12. And in this one, I expect this. That's what I want to see is that I want to. This is the final answer. Okay. That's the form I'd want you to put it in if you started out with this problem like that. That makes sense?
Yep.
Okay, that's all we're doing here. So you can, I could have turned both of the whole number, the mixed number into an improper fraction and did it that way. I could have done that and then added together. But you're going to end up with the same thing, however you want to do it. But you got to keep track of all the parts. Okay. Okay, moving on. So, looking at my test here. Um, Another one, not random, but solve for missing terms, such as if I had like 3/4 is equal to say x over and solve for x. What would I do in this one? I want to know what x is. How do I solve for x?
You'd cross multiply.
Okay, I could cross multiply. If I cross multiplied, I'm
It
going to get,
is 4x times 15.
well,
Wait, hold on.
you don't need to,
I
when
messed
you
up.
say cross multiply, you don't cross multiply everything, right?
Oh, okay.
I mean, yeah, I wouldn't cross multiply. What I would do is I'm gonna see if I can show you here this. Okay, I'm just gonna have to like this. What I would do is I would take this and multiply it by 5 because this is x over 5, right? So if I do that on the right side, I have to do it on the left side. So it looks like that. So now all I've done is I've multiplied both sides by 5. So now I can cross out that 5. So, right? So now I'm going to flip
Mhm.
with the x on the other side. And it becomes 5 times 3 divided by 4. Right? And this becomes 15 over 4. Does that make sense? All I'm doing is
Mhm.
I'm getting x by itself on one side. So I'm not really cross multiplying. I'm just multiplying both sides by 5. So I don't want x over 5, I want x. So I have to have x in the numerator here so I can cross that x out with that x, right? I just factor it out.
Mhm.
Okay, so it ends up being 15 over 4. So if I say, okay, I want this in a mixed number form, what do I do?
I do 4 divided by 15.
Well, 15 divided by 4, but you're right.
Well, yeah,
That's what you meant.
yeah,
Right? Yeah.
yeah. That's exactly what
And
I
4 into
meant.
15 is what? How many times 4 go into 15?
It's gonna be 3 times.
Okay. So it looks like this. Remainder 3, right? Okay, Lucero, what's this in mixed number form? When I do this, then I want to put it in terms of a mixed number. What's the mixed number going to look like?
3 with 3 over 3.
Well, you got 2/3 of it. It's 3 plus 3 over 4, not 3.
Oh.
Right? It's over, it's over this divisor, right?
Okay,
You
yeah.
got it right. Right. So just don't make that silly mistake, okay? So it's just 3 and 3 over 4. Okay? Okay, so this is the same as this. I just put it in terms of mixed number. Okay? Okay. Moving on. Okay, understand rates and bases. Remember we had that formula. Let me do the board here. Where we said rate is equal to part over base, right? And we really, if we said the rate, and we want this in percent, we multiply it by 100.
What page would this be in the book?
Oh, I have no idea. It's in, I don't know.
Towards the beginning.
Yeah, it's definitely during the beginning. Right, that I can tell you. It's in there. I honestly don't know where.
And yeah, okay. Anyway, be
Okay.
part over me.
If you find it, share it so Lucero can know where you are too. If they don't know. We talked about it, obviously.
It doesn't matter.
Yeah,
Later.
question. I just don't have the answer. Percent formula, solving for base. Okay, look at page 268.
6, 8.
So it's got to be in that area. It's page 266. Solving for part, solving for rate. Okay, got it? Lesson 3.
Okay.
So that's the formula. So if you take home pay is $2,400. He makes $2,400, and okay, $2,400 a month, and he spends $400 per month on rent. That's pretty cheap. On rent. Okay. Okay, what would be the rate? This is not a very good problem. If I would put this in terms of rate to part to base, if I wanted to figure out what the percentage that he spends on rent, how would I use this formula to do that?
You put the 400 over
Yep.
2,400.
Yep. And if you take that and you multiply it by 100 to convert to percent, and this would give you your rate. So the part would be 400, the base would be 2,400, and the rate is that decimal portion, and multiplying by anything by 100 will convert it into percent. So it'd be 400 over 2,400, which is like 1 over 6 times 100. So what is that, 16 or 16.6% or something like that, right?
Mm-hmm.
Isn't that what that would be? 4 divided by 20. Yeah, it's 16.67%, or it's 16.7%. That would be the rate in this case, right? And there's other problems, but what if I said, what is what percent is 90 of 270? How would I do that? This would be of 270. What percent is 90 of 270? How would I use that rate base equation up here?
When you put 90 over 270
And then what are you going to
100.
times 100 exactly? Okay. It would be like that. So it would be 1/3. 9 over 270 is 1 over 3. So it's 33.3% is what it would be. Okay. $120 is 25% of what number? How do I set that up? $120 is 25% of what number?
It would be what's the amount again?
It's $120 is 25% of what number?
Wouldn't you do the 270 or 120 times 0.25?
No.
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 In the other.
You got it backwards, right? And so the rate is 25%, right? We know that,
Oh, okay, rate is percent.
right? So where's my? So the rate, in this case, it's 25%. And we're saying, I'm asking the question, $125 is what part of? So it's $125 or 100 was 120, $120 over this base, this X. That's the only thing we don't know here. We know the rate, we know it's $120, but we don't know the base, right? So you've got to solve for the base. So you have an algebra problem. You got 25 is equal to 120 over x. I want to solve for x. How do I do that? How do I solve for x now?
Then you divide 120
Yeah,
by 25.
yeah. And then what do you do? Where's the x go?
It goes with the 25.
So in other words, the x goes on top, right?
Yes.
You're saying it's like that.
Yes.
Right? Exactly right. Okay. And in this case, it would be, we would convert this into a rate, so it'd be 0.25, right?
Mhm.
Because it was a percent, but we don't want percent, we want decimal form to solve for this. So it'd look like this, right? So in this particular case, you are cross multiplying. You put the x on top here, you bring this down here. That part you're cross multiplying, right? You've got to get x on top. So in this case, it ends up being $480 is the answer. Okay. That makes sense?
Yeah.
That's how you use this, okay? So there'll be something on that. Okay, let's take a 10-minute break, okay? And because I've got quite a bit more to go over, we'll have to go a little quicker just to give you an idea of the areas that'll be on the final, okay? So take a 10-minute break. I'll see you guys in 10 minutes. Okay,
Oh.
okay. So,
Where's my phone? Where the hell is my phone? Mommy, where's my phone? No. Where's my phone? There it is. Found it, mommy. I found it.
Guys, hang tight. We are going to a call. What's up, Ash? Good to see you, bro. You guys hang tight. We're going to a call. More neighbor disturbance. What's up, Rice Krispie, Rock City, Central Heavy, Locker? What's up, bro? Hit the thumbs up. Bro. Brian. Thank you. Forgot and some clean sauce. This is what we do. This is what we do. We report police. Cop watch. Cop watch. Shh. 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 Quiet. Quiet. What? We're just recording the police. We're not trying to put anybody on.
I know, but it's a really personal issue between my sister
Well, actually, we're just making sure that the police don't rough nobody up. That's it. That's what we do. It's my First Amendment right to be out here. This is what I do. This is my job. I'm not. Well, look. I can't even really hear nothing. Actually, if you want to put all the, you're giving. Look at. I'm live, and you're giving everybody information that you don't need to. So let's just all calm down. I'm here to record the police. I'm not getting nobody's. There's no reason for the police to put their hands on anything. Exactly. That's why we're here. Have a wonderful day.
Right here, baby. Oil spills all day, baby. Go get a job.
From my understanding, there's neighbors.
Job, a real job. Right here, baby. Oil spills all day, baby. Go get a job. Bitch ass nigga. Pussy ass motherfucker. Hey, I'm standing behind that camera. You gonna put it down low? You ain't gonna put it down low? Fuck, go get a job, you fucking lame.
Educational process.
Put it down low. You ain't gonna put it down low? Fuck, go get a job, you fucking lame.
Educational process.
Here.
Sorry about
There.
that. Yeah.
It's all right.
Lucero, did she say anything to you when she left? No.
Uh-uh.
Okay, darn it. Okay.
Mm-mm.
Well, okay, her loss, I guess. Okay, so hey, the key is if you look at all the quizzes and all the keys and all the quizzes, that's all the important stuff. I'm trying to boil it down here into into a meaningful review. But if you review that, Jessica, you'll do just fine.
Oh, okay.
Okay, so that's one interest point. So just remember that and look at your quizzes.
Yeah.
Let's do one on simple interest. I'm going to share with you the full version of the. Yeah, let me see, full screen. Let me see, share. Yeah, here. Can you see my screen now?
Yeah.
Okay. Yeah. These things. This are, okay, you see number 10, there'll be a problem on interest. You know, if you're given a principal, you're given the interest in percent, and then the length in years, you can figure out what the interest payment would be, right? Simple interest, not compound, just simple. So in this particular case, it would just be 5,000 times the percent, which was 10%, so it would be 10% divided by 100 to convert it into decimal form, times 3 years. So it'd be interest is equal to principal times interest in percent divided by 100 times number of years. That's the formula you would use, okay?
Mhm.
In this particular case, it would be quite simple. Go to my whiteboard, get rid of this stuff. New. So then interest,
There it is.
okay, is just equal to principal, or say it was $5,000. And it would be times the interest rate of, if it was 10%, it would be 10 over 100. And then that would be times the number of years, 3 years. Because this 10, this is per year. That's where the
Yeah.
per year is. So the year get out of there when you're done. And you end up with $1,500. Okay. That's how you do those. Okay. So pretty straightforward. Just
Yeah.
got to know that formula. Okay. Moving on. There'll be one on the graph like this. Let me stop sharing that and go to the next page. Back to my page here. One where you'd have again, we're just interpreting graphs, getting data off of graphs so we could figure out what we're trying to do here. But determine the amount of dollars invested in mortgages if the total investment was $100,000, $1 million. And this graph, it shows by percent how their investment is spread out, right? Private bonds, mortgage, real estate, public bonds, stock market. Not very much in stock market, but in mortgages, it's 20%. So you'd say the 20% divided by 100 or 0.2 times the total amount to get you the amount, right? That's
Yeah.
how you would get all these parts. Okay. Know how to do. There will be one on finding the mean, median, and mode. And all these kind of problems, the first thing you do is you put the data in order from low to high. So you rearrange all this data. That's the first thing you do. And then check them off as you do them. Make sure you don't miss any parts. The second important thing is count up whether it's an odd number or even number. If it's even number, then you take the middle between those two, the middle part, and to figure out what the median is, because that's what the definition of median, right? Is
Mhm.
it's looking at the data points. The mean is just the average. It's all these added up divided by the total number. That's the mean. So the median, you got to look at the set of data, find the middle point. If it's an even number, you take the middle, if it was like 10, you take the middle between 5 and 6, the average of that between 5 and 6. If it's an odd number, you just take that middle point, and that becomes your median. In the mode, you could either have a mode or not have a mode. If it's the number of data points that are the same, that would be your.
Oh, yeah, I remember that part.
Remember
So
that?
it'd be
Okay.
8.
So in this particular case, it would be 8 because it would be 2 8s. Okay. So that's how you analyze a set of data. So you'll be given something like that. Okay. You'll be given some probability problems like this,
Oh, yeah.
right? Remember how to do these? Remember if you
Months ago.
got marbles in a bag, and what you want to do is you add up the total opportunities. In this particular case, you'd have 5 and 4 and 3, and it would be 19 opportunities. So if I said, what's the probability of getting of red, it would be that 5 over 19. That would be the probability. It's really that simple. Don't make it any harder than that, and convert that to a percent or whatever I'm asking you to do. Okay, that's how you do that. Okay. There may be a combination problem. There may be a permutation problem, maybe. If it's a combination problem, this is the total number of options, the total number of combinations. In this particular case, you've got somebody making soup. You got 4 different ingredients, and there's 4 meats, 4 vegetables, 3 noodles, and 4 So you take the max of each one of these and multiply them together. So it'd be 4 times 4 times 3 times 4. That would be the combination, okay?
Yeah.
If it's a permutation problem, this is an order of putting things in order. If you have 4 paintings, the number of options would be 4 times 3 times 2 times 1. That would be the total number of possibilities of rearranging those paintings, okay? That would be a permutation problem. The other one would be a combination problem.
And that's where you God, what am I trying to say?
You're figuring out the
Just
number.
times like the first, like each ingredient
Well, on
go
the,
down one.
yeah,
Is that what?
yes, for the permutations,
Yeah.
it's 4 times 3 times 2 times 1.
Yeah.
Right.
Yeah.
Okay. But if it's combinations, it's the total number times options in each class. So that's
Yes.
what I mean. Combinations, it would be 4 times 4 times 3 times 4. Permutations, if there's 4 paintings, it would be 4 times 3 times 2 times 1. Okay. That's the big difference. So
Yeah.
permutations is less.
Yeah.
Okay. Okay, something on solving expressions, in other words, simplifying things.
Yeah.
You know,
PEMDAS.
yeah, exactly. There you go. Using the order of operations to do it. Exactly. That's what that's all about. Expressions, 4 to the second power would be 4 times 4. If it was 4 to the third power, it'd be 4 times 4 times 4.
Mhm.
If you have a minus exponent, you want to change that to 1 over that to make it a positive exponent. Then go ahead and multiply it.
So it'd be 5. I'm sorry. Wait.
I can show you.
Yeah, I forget what.
Yeah,
trying to say.
let
Oh
me-
yeah, it'd be the top over the bottom, right?
Well, you would change it. Yeah, you would.
Yeah.
If I said it's 3 to the I did it like this, and I for this number I said it was a minus 3, that top number, right? Let me put that in terms. Do it like this. So it's easier to see. Stuck here. Get my writing utensils out. Just a minute.
Mhm.
So the 3 to the minus 3. First thing you want to do, you want to put 1 over 3 to the 3, because there's an exponent rule that says if you have 3 to the minus 3, you can invert it and make it 3 to the 3. It's exactly the same thing. It means the same thing. But now I have it in a form where I can easily convert that to a number. I can say it's 3 to the third power is 3 times 3, like that, right? And that whole thing is equal to 1 over 27. So if you had something like that, I would say
That's
this
what
would be the answer to this. Okay, that's how you
it'd
do it.
be 1 over 3 cubed.
Yeah, exactly.
Oh.
So if it was like 5 to the negative 2, it would be 1 over 5 squared. Okay.
Oh.
Okay, that's the secret on that one. Okay. So know that. Okay, moving on. That's what that's all about. Remember, anything to the 0 exponent to
Is
the 0
1, right?
power is equal to 1, exactly. And then if you've got a radical, understand the radicals.
What do you mean?
I'll show you. Here's a radical. If I have a deal, come on, Delson. If I have that is a radical sign. So if I had like 4 in here, and I said simplify this radical, well, this is a square root sign. That's what that's a radical for the square root sign.
Oh, it'd be 16.
So look, oh, no, but look inside it. This 4 is equal to 2 times 2. That's his
Yep.
factored form. Well, now and this thing is the same thing as square root of 2 times the square root of 2, right? So it's the same. So this, if I'm looking at the square roots of two bases, the result of that is just 2, right?
Ah.
How to explain this? The root of 4 is 2. And
Mhm.
so I'm just trying to show how you get there. 4 is the same thing as 2 times 2. That's
Oh,
the
yeah.
factored form, which is the same thing as the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is equal to 2. And you could show this and prove it because 2 to the square root is 2 to the 1/2. That's what that is. That
Mm.
times 2 to the 1/2. That's what, so it's the same thing. So this becomes 2 to the 1/2 plus 1/2, which becomes 2 to the 1, which becomes 2. It's a long way of saying that this is this. So this is this, but that's how I prove it, okay? So the square root times the square root of any base will give you that base, okay?
Oh,
So if I had the square root of 81, what would the answer be?
9.
Exactly, okay?
Square root of 9 times 9.
Exactly.
Oh.
And then even to make it a little more complicated, what if I had like the square root of 27? It's supposed to be a 27. How would I simplify that?
Uh,
I'm going to show you how. 27 is the same thing as 3 times 3 times 3, right?
mhm.
Right? So
Yeah.
I can look at these two and pull one out on the outside. So it becomes 3 times the square root of 3, or yeah, square root of 3. This is the same as this.
Hmm.
Well, if I say, and I'm not going to, we really
Yeah,
didn't
yeah.
spend a lot of time on that, but if I said simplify this radical, this would be the simplified version because I was able to pull out 3. Okay.
Oh, I don't know how I forgot that a little bit. That's
Yeah,
funny.
well, you don't use it, that's why. But
Yeah,
what is it? I
that's
mean,
a good.
it's something, not something you'd use at a grocery store or whatever. The square
Yeah.
root of 8, right? It'd be the same thing. 2 times 2 times 2 inside the radical. Then I can pull out 1, 2, and I could say it's 2 times the square root of 2. This is the same thing as this. Okay.
Okay.
Anyway, it all goes back to understanding the bases or the roots. That's all we're doing, right? But you can pull them up. Okay, that's the long version of that. So let's move on. We got a lot more to do, but that's
Yeah.
that's what that's all about. Okay. Um, okay, let's see what else is on the test. Oh, standard notation, decimal notation. Know how to do that, right?
Yeah.
So
That's the what was it? The 10 to the power.
yeah, the 10 to the base 10, yeah. So if you had 123,000, and I said convert that to standard notation. I want it to the 10 power, something to the 10 power. So I'd go back and find out how many decimal places we got. 1, 2, 3, 4, 5 to get a whole number. So it'd be 1.235 times 10 to the 5th power. This would be the scientific notation of that. This would be standard form. This would be scientific. Does that make sense?
Yeah, and the
I
other
just
one is
going
that's
backwards. Right. If you had
a negative.
a negative. So if we had well, let's do it like this. If I had this
Mm.
and I said, okay, give me standard notation in that, I'd move the decimal place to the left 3 places. So it'd be 1, 2, 3. So it'd be 0.00015. And this would be, at this point, it'd be 10 to the 0, or just, this would be your answer. In standard notation. I just move it back 3 places. You see that? One,
Yeah.
2, okay. Now, let's go what if I had, well, that's just what I did. What if I had 3.521 times 10 to the 5th? What would that be in standard notation?
You would move it over 5 times.
To the right, right? 2, 3, 4, 5. So 3, 5, 2, 1, 0, 0. I think 1, 2, 3. Yeah, something like that. So it's 352,100. Okay.
Yep.
That makes sense, right? That's how you do these. Okay. Okay. Let's go back and see where we are here. Okay. That's what that's all about. And then simplifying using order of operations. If you see something like this,
Mhm.
you want to take care of things inside the parentheses first. Then in this particular case, it would be 16 minus 12, so it'd be 4 squared, right? That would,
Mhm.
this over here would be 2. It would be 2 divided by 2, which would be 1. So you'd have 3 times 4 squared minus 1. So it'd be 4 squared is 16 minus 1 is 15. 15 times 3 is 45. So it ended up being 45. Again, you're just use the rules of order of operations, like you said, Pembroke, and do it that way. Does that
So
make
the last part would be,
Yep. Would be
um,
3 times everything inside here.
Yeah.
It's like a square brackets on the outside. See?
and then you take 12 minus 10. And so then it would be 2 over
It's not-
2.
No, it's
which
not
is
12. It would be 4 squared or 16.
Yeah.
16
I
minus,
just meant the last part.
yeah, minus 16 minus 2, or so I did that wrong. Or it would be like 14.
Yeah.
Right? Because you,
Yeah.
well, wait, no, back up. No, it's minus 1, 16 minus 1. Because this is 2 divided by 2 is 1. Right? So it'd be
Oh,
6
yeah. That
minus
is
1 is
true. I got
15.
correct.
Right.
Yeah.
And then that 15 times 3 is 45.
Yeah.
Okay.
Okay. I remember that.
That's how you do that. Remember, in absolute values, it's just
They're
a
positive. They changed the
it ends up
sign.
being positive. Yeah, it ends up being +5. So it'd be a +5 minus a +4 plus 20. So it would be a +5 minus a 4, which is 1,
Mhm.
plus 20. So it'd be 21, right?
Yep.
Okay. Understand the greatest common factors
Mhm.
and the least common multiplier. The greatest common factor, you know how to do that.
Mhm.
Here's how I do it anyway. You can do it a couple different ways, but greatest common factor, show you. So let's say you had numbers like, I'm just trying to figure out, I don't know what it is, 12 and 32. What would be the greatest common factor of that, of both numbers? So you take the 12, you take all the factors of 12. 1 is 1, 2, 3, 4. There's a lot of 6. You got to go up to 12, right?
It'd be 12.
No, I don't think so.
No.
1, 2, 3 doesn't go. 4, 4 go. Yeah, 4 goes because it was
Oh, yeah.
right. 6 doesn't go. 5 doesn't go. Of course, 6 to 7 to 8 8 doesn't go, 9 doesn't go, 10, 11.
So it'd be 4.
It'd be 4. Yeah. Yep. Boom. That's how you do that, right?
I remember that.
And then least common multipliers is those are the numbers bigger than the largest one. Okay.
Mhm.
So if you had like 12 and 20, you'd take multiples of all these numbers: 12, 24, 36, 48,
What?
60, 72. It's going to go keep going. 72, right? 84. I'm just taking multiples of 12. Going to keep
Oh,
going,
gotcha. Okay.
right?
Yeah, I was confused.
Yeah, 20. You're going to take 20. You're going to take 40. You're going to take 60. You're going to 80. Well, you can see 60 is your answer right here.
Hmm.
That's the least common multiplier. It's got to be larger than the largest number. Okay, least common
Oh,
multiplier. That's how you do those. Does that make sense?
yep.
So understand that stuff. Okay. One of those problems, either least common or the other one, will be on the test for sure.
Yeah.
Okay. Moving on. Know how to simplify terms. You
Oh,
know,
yeah.
remember how to do that. Know what a like term is. You can look for the like terms, right? So in this
Yeah.
one up here, x to the third power, that's a term that doesn't have, there's no other term like, there's one of those, right? Add the x squared, you've got a minus 5x squared and a 15, so that's 10x squared.
Hmm.
You boil this down. So simplifying, you'd have 10x cubed plus 10x squared plus 11x minus 10. Those would be
Yeah.
all the terms you'd end up with, right?
Yeah. I remember that.
Okay. And then understand, and then know how many terms, how many different terms you have, understand the concept, what defines a term, right?
Yeah.
Okay.
Same
Uh,
power
you
and
know,
same.
yeah, they all have, I mean, like j squared would be, we would add that one and that one. K cubed, there's two of those. J
Mhm.
cubed, there's only one, and there's a 5. So you end up with 4 different terms,
Yeah.
right? How many terms? Okay. Know how to multiply binomials by monomials, and know how to
Mhm.
use the FOIL method. Remember
Yep.
how to do the FOIL method?
Yes, I do.
Okay, so we won't, and then dividing a binomial by a monomial. You have to divide it. It's just like dividing a fraction.
Mhm.
Um,
Oh yeah, you do the x's, so it'd be 36x and not
yep. And
because
then
it
what would be the other term?
would be 4x.
4x, exactly. Well, it's just 4.
Oh yeah, yeah, because you take the x's out.
Yep.
Yep.
So it becomes 12x plus 4. That's your answer,
Yeah.
right? When you're done. Okay.
Uh,
Excuse me, know how to solve for the variable and check your work,
yeah.
right?
Yep. I remember
Okay,
that one.
you know how to do that. Excuse me.
Oh,
Okay.
these ones I have issues with. I don't
What,
like it.
all the word problems?
Yeah.
Yeah, well, most people do, I think, myself included. It's always a little tricky. Okay, write the problem as an algebraic expression. The difference of 3 times the number, that number always referred to as like x or y or something. And
Yeah.
6, so that when they say the difference, it's got to be the x minus 6.
Yeah.
And it's equal to 15 plus 2 times the number. So it's 15 plus 2x,
Yeah.
right?
Yeah, that one's easier.
That's easy, right? That
Yeah.
is easy.
It's the
Okay, and then what about factoring? Let's spend a little time on factoring, okay? Factoring quadratic equations.
mhm.
Okay, so let's go here. And New. So I'm gonna throw one out, and I don't even know if this is gonna be factorable. I probably shouldn't. Yeah, that's the problem with, if it's always factored by the quadratic equation or the
Yeah.
quadratic formula, but we're not doing that. But plus, let me look at my book here and make sure we get something that works. I'm looking, let's see. Track.
That's right.
Um,
I don't remember.
go backwards. I'm just gonna throw one out here. I don't know. Plus 4x minus 16. No, minus 20. I think that's gonna work. Just a minute.
Yep.
Two. I'm gonna change this to a 9.
Oh, we're not gonna do that one.
Okay, we can do this one. This is gonna work. So if I have this, so what do? You gotta look at two parts. You look at that last term, and you know that if it's factorable, it's gonna be, when I look at my equation, because we're doing it like this, x plus b times x. When I'm looking at this last term, I know it's going to be this times this. So this is factored. What that 20 means, it's factored. So what are some ways I can get minus 20 in this equation? Well, I could say one would be minus 20 times 1, right? That would be
Yeah.
one factored. Another one would be minus 10 times 2, right? That would be another one. Another one would be minus 5 times 4. There's just a lot of them, right?
Yeah.
And plus I can switch these signs around too.
Oh, it's gonna be the 5 and the 4.
There you go. See, so you're getting it. So, and we also know the sum in this particular case has to add up to 9, right? That's what that tells you with that 9 there. Okay. So how do you get 9? Well, one way here's the other deal. It's not 5 minus, well, these are positive. So each one, I should have a negative sign in front of each one of these guys. I'll show you what I mean. Tilson. What I'm saying is, yeah, since it should be negative,
Mhm.
or it
Yeah.
could both be positive, right? But no,
Because you're subtracting.
yeah, no. I'm backing up now. No, it should be. It's going to be negative.
Yeah.
It has to. One has to be negative. So
Mhm.
it's either one or the other, but not both of them.
Yeah.
So what that tells me is that this doesn't work. So yeah, it does. I can use a minus 2 and a, no, I can't. 5 and a 4. I can use I can't do that. I can make this, if this was a 1, I could do it.
Mhm.
Let's assume I was trying to get 1. Well, how would I get 1? I could get 1 by using a plus 5 and a negative 4, right?
Mhm. Yeah.
So the point is, you're going to be given one that does work.
Yeah.
And the sum of of the two numbers has to equal that coefficient there. If this was a 1, I could use, oh, it's going to be a 5 and a -4, or excuse me, a +5 and a -4, because if I put it in, it's going to be negative, it's going to be +5. Right?
Mhm,
Do the FOIL method of this just to prove it. It's going to be x squared
mhm.
minus 4x is going to be another term, minus 5x, or excuse me, plus 5x, and -20, right?
Yep.
This is going to be x, right? So I know this one works. Anyway, that's how you do this, right?
Yeah.
You factor that third term and you add those two factors together to equal the second term. If you do this, and if it doesn't work out, if you can't make it work, then you have to use the quadratic formula. That's x is equal to b squared minus 4ac all over 2a. You'll get that in the next couple terms. In fact, I think you might not even get it till Math 95, but you'll get it. It'll come. Okay, so all I wanted to do is make sure you understood how to get the factors, how to get the sums. Okay.
Yeah.
Okay. What else I've got left here? One bag of tricks here. Okay, so know how to, how to, you can see my chart, my page, right?
Yeah.
Know how to fill out the XY table. If you're given this formula, know how to do this, right?
Yeah.
So it would be just, if it was -4, it would be 2 times -4 is 8 minus 7. So that would be I can't write on that. Why can't I write? I guess I can't. Yeah, I can't write on that. Anyway, so it would be -7 plus 1, or -8 plus 1, which would be -7. Anyway, you get all your points and you'll have a straight line, right?
Yep.
By plugging in those values, okay.
Yeah.
Know how to find the slope intercept. Use the slope intercept to find the equation, right? If you're given a point and a slope, understand that. So
Yeah.
you know how to do that?
Yeah.
Okay. Okay, then I won't go over it. Okay, understand what the domain and range mean.
Yeah.
Okay, the domain is any value on the x-axis. So if you look at this parabola, this thing keeps going and going and going to infinity. So it's always got an x value, negative, it's always got an x value positive, right?
Oh
Can you
yeah, it's the
visualize that? You would always have
positive
one
infinity and
and negative infinity. You'd always have
negative.
one on
Yeah.
on this line, there'll always be a point on the x-axis that satisfies this equation. That's what that means.
Yeah.
Okay. Now, that's the domain. Now, the range is the y values. Well, you can see this, if this thing crosses it, if you could see it at 2, there's nothing below 2 on the y-axis, right? There's no 0, there's nothing down here. So
Yeah.
that means that range starts at 2 and goes positive.
Mhm.
So the range becomes 2 comma and then plus infinity. It just keeps going up, right?
Yeah.
That's what that means, okay? Of
It's
course,
all and it's only positive infinity.
exactly,
Right?
yeah. It's not negative. It doesn't go below, 2. So it never reaches a negative number.
Yep.
Okay. Some plane figures. There's two-dimensional figures.
Yep.
A rhombus, rectangle, parallelogram, trapezoid. A rhombus is just any four-sided figure, basically, any four-sided figure. A rectangle is where the opposite sides would be equal, and there's 90-degree angles in there. That defines that. Parallelogram is two opposite sides are equal. So this thing here, there's 10 and 10 and 15, 15 would end up being a parallelogram.
Yeah.
Trapezoid is anything where just there's two opposite sides of parallel lines. Okay, that's a trapezoid. So those are the four options. Remember that all the interior angles of a triangle is equal to 180 degrees, right?
Yep.
All the interior angles of a four-sided figure has to be equal to 360 degrees. Okay. Understand how to classify triangles. Remember, by side length as well as by angle measures. Side lengths would be like an equilateral triangle where three sides are equal. Isosceles, two sides are equal. And then a scalene would be no sides are equal. They're all different.
Mhm.
So those are the three sides for when you classify by length. By angle measure, it's where the three angles are equal, or excuse me, no, it's where you either have a right angle, that would be one, or all the angles are less than 90 degrees, that would be an acute. And if one angle is greater than 90 degrees, it would be an obtuse triangle. So
Yeah.
you have a side element to it as well as an angle element to it. Okay.
Yep.
And when you look at triangles, look, if you see cross-hatched lines like this, it means they're equal.
Parallel. Right.
They're well, not parallel. A to B
The
is the
same.
same length as A to C. That's what that means. Okay. And when they split this down here, it means B to D is the same length as B to C because it's got one hatch down here, right? And also that this is a right angle. That means 90 degrees here and 90 degrees there. Okay. Okay. If it's isosceles like this, where two sides are equal, it means that these angles are equal. You don't know by what angle, but you know that they're equal. Okay. 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 Find the area and perimeter of a figure. Remember, area is equal to 1/2 base times height. Base in this case is the small b. It's not the capital B. It's the small b times the
Why
height.
that again?
Say what?
Why is that a small b?
Because it's just this. It's the length of this edge
Okay.
here to this edge here. It's 12. If it was capital B, it would be an area. Remember, the base is the area when we talk about surface,
Oh, okay.
right? So that's
And
why I
this,
say it's small b, okay, lowercase b. So in this particular case, what would the area be of this triangle? With this definition or this formula, 1/2 base times height, what would it be?
had the base would be six,
No,
right?
no. Why do you get 6?
Because it's half
No, it's not half.
of
Oh,
b.
it's 1/2 times 12. Is that what you mean by 6?
Yeah,
Yeah, okay, okay.
so that would be 6.
Yep, that would be 6. And the height would be
4.
4, right? Multiply them together.
Yep.
And so you've got 6 times 4 or 24. So 24 square units for that, right? Okay.
Yeah.
Okay. And what would be the perimeter?
All those added together,
Right. So
9,
9 and
12,
12.
26. Is that what it'd be?
Right. 26. Exactly. Yep. Don't worry about the 4, but you get the 5. Yep. Okay. Volume of a rectangular prism shows like it's just a box, right? The volume is equal. Here you got capital B, right? The base, the top or the bottom times the height, right?
Yeah.
So this particular one would be like 45 times 25 times 15, right?
Yeah.
That would be the, okay. And what's the volume of the cylinder? Here's the formula, base times the height. The base in this case is 3.14 times r squared or pi r squared. That's the area of a circle. And then just times the height, right?
Yeah.
Okay.
So the height would be 8. Okay.
Yeah, 3.14 times r squared. That would be,
It'd be 4, so it'd be 16.
yeah, it would be 16 times h times 3.14. Okay.
Yeah. Oh,
And remember whatever your units are, they're in cubes, right? If
yeah.
it's inches, feet, or in this centimeters, so it's cubic centimeters would be your answer. Okay.
Okay.
It's important to have those units right.
Okay.
Okay. Okay. 42, find the volume of the right cylinder cone shown below. This is a cone. So the formula is 1/3 times the base times the height. The base in this case is just the area of the circle on the bottom, right? Pi r squared.
Yeah.
We've got it right here, 3.14 times r squared. And the height is whatever it is. Okay, it's right here. It's 20 inches and the base is, the radius is 10. So plug all those numbers in and you'll get inch cubed. Okay, 43. In the function below, oh, we're back on this stuff. Okay, this is actually the last one I had. Oh, this is just solving for one variable when you know the other variable, and that was putting in 21 for x and solving for it. And don't forget to use rule of operations to do it, right? Or you won't get the right answer. You know, you could get the wrong answer. That's all on that. And that's so the final is just going to be abbreviated version of this. Okay.
Okay.
So if you know all this stuff, and I think you do, you should be fine.
Yeah.
And if they and when you talk to your advisor, just let them know that I feel confident that you could take that Math 66 class.
Okay.
Fine. I just hope it's all. I just don't. The unknown is whether it's going to be offered or not. I just don't know.
They might not have.
They might not have it only because of COVID, because that has to be. We have. I can do the other online, the lecture online, but I can't do the lab part. It's supposed to be hands-on, and it's
Like, what do you mean?
well, that's what I
Hands-on?
mean. Hands-on means you have to be in a class.
Yeah.
And
Oh,
so I can have you, okay, now come to the board, Jessica, work this problem. That's what I
Gotcha.
mean, hands-on. And there's
Gotcha. Okay.
actually going to be myself plus a helper to help me with people. And so it's pretty well like a one-on-one situation helping you, which is pretty neat, really.
Yeah.
But they
Yeah.
won't have it if, depending on the restrictions, that's the problem. So
Gotcha. So if they don't have it, then what would be available to take?
then what you would have to do, you'd either take Math 60 or you'd
No.
wait to the spring term and take 66 again. Take it
Okay.
when they do have it. So
Okay.
you have that option, right?
Gotcha.
I just wish I just wish I could
Mm.
guarantee that they will have it.
Yeah.
I've got some people signed up. I've got of the 9 people signed up, there's 6 of these people have already taken Math 60, so they're just taking the 65. 3 of them have not taken 60, so they're assuming that they're going to have that we're going to have this one-on-one help. If we don't have this one-on-one help, those people are going to have to go back and Math 60. It's a screw
Wow.
thing. Yeah,
That is.
it's going to mess up schedules, and I think what it means is that those people would want to wait till the next quarter when we do have the Math 66.
Wow.
Anyway, it's goofy. I'm sorry. You wish it
Yeah, I mean, it's
clear,
with
but
the
just the way it
my
is, you know.
school too. It's
Yeah.
just hard.
Yeah, it's definitely
Yeah.
hard. But so next quarter, what do you plan on taking other than the math? Anything or?
Well, it depends on what I get for financial aid.
Okay, sure.
I mean, I can only take one class.
Yeah,
You know, if we don't have the math thing,
right.
I might take like a writing or
Yeah.
something like that. But I'm hoping.
Sure.
Well, here I have the option to do 60, so
Yeah, you could
I think we'll
definitely
do
do
math.
60.
It's just
Uh,
my favorite subject out of everything.
All right.
It really is. Yeah.
Yeah, I understand. No, that's great. What do you think you want to do when you have some more classes? What's your goal?
Well, I'm trying to become a vet tech,
Okay.
like the medical assistant at a veterinarian's office because I
Yeah.
love animals and they love me, and it just be
Yeah, no, that's
something
very
that's
neat.
awesome. Yeah.
Yeah. No, that's neat. Well, I'm sure you
Now
can,
that my back has healed enough,
yeah.
I can do stuff. So I'm excited now.
Well, that's awesome. Yeah, I think that would be a
Yeah.
neat job to work with animals. I agree with you there. That's cool.
Yeah.
And the math is not going to hurt you for sure. It's good for you.
No, it will not.
No,
Yeah.
so always good. Okay, well, that's about all I got for today. Okay.
Okay.
So
Are you gonna send the practice version for the?
oh yeah, right. That's a good point. I'll email it to you because
Okay.
I put it in Canvas and I know you have a hard time getting in Canvas,
Yeah,
right?
I don't understand that. When I talk with Blake, I'm gonna ask him
Yeah.
about it.
Yeah, because going forward, you're gonna,
I don't like.
yeah, you
Yeah.
need to figure that out. But I'll go ahead and send that. It's a, yeah, I'll send that version, not with the answers, but it's got all the
Oh,
questions.
no,
Okay.
no. Yeah, of course not. Of
Okay,
course.
I'll do
Okay.
it in a couple seconds. Okay, you take care. See you Wednesday.
You
Okay,
too. I'll see you Wednesday.
thank you. Bye-bye.